Okay, I'm recording. You can go ahead and get started.
Okay, so welcome everybody to our presentation for shop use brake shapes and steel. This is our new edition for this presentation, and the reason is because I already did a presentation previously, and I'm still waiting the presentation for the next week from Eric too, who is going to be talking about doors, and hopefully it will be great. Yeah, so very soon. Thanks for volunteering yourself, Eric. Okay. So this brake shape presentation, we're going to be talking about the shop use brake shape and the steel. And basically, let me present myself. Saul Garcia, and in the team is Sean Dooney.
Hello.
I'm there. Very good. Okay, so we are part of the panel team group, and just one side of the one side of the panel group. It's the shop use brake shape team, and that's Sean and I. Okay, so for this presentation, basically, we're going to be covering three important things, and that's the most important that you're going to have at the end of the presentation. Understanding when and why it's a brake shape important. Second, it's how some of the decisions during the drawings or the drafter are doing, it's reflecting on the fabs. And finally, the last third important thing, it's how can we improve better brake shapes. Okay, so the first thing we have for our presentation, it's to understand what is brake shapes. So basically, you can see some of the examples we have for the brake shapes here. There is different kind of things what we call it a brake shape. It could be a cap, it could be an end dam, it could be a stack joint end dams, and basically, even for example, the splice leaf. So a brake shape, it's used for cover any we have some standard brake shape, like the one that you can see. It's covering some holes or some stack joints or different condition. Those are the specific standard brake shape. But additionally, as you can see, we are using some brake shape to attach parts when we have different angles, when we have different condition, like our extrusion are not enough, then it's the time when we are using this kind of brake shapes. And we are gonna talk a little bit more on this presentation. So we normally use a brake shape anytime in the project that you have a close or a non-normal condition or an angle, as I mentioned to you. This is an easy solution to join our system together in other cases. So there's some example here. What are the most frequently material used? Well, it's aluminum, and here is for the brake shape. As you can see, those are the thickness of the materials, and we have and steel, different miscellaneous steel parts. But basically, for steel anchor clips and kicker reinforcing, we are using steel with the ASTM grade A36 steel for those one. And for steel shape, like tube shapes, we use ASTM A500 grade B with red oxide primer. If it's not listed here, any of the other steel parts, then we are going to be using steel grade A36 with the same finish, red oxide, unless it's defined as a painted part or a visible part for the steel. But this is the most frequently material used, and this is what we want to cover here. When the brake shape start weeks, well, we call it the brake shape week. This is, of course, 3 weeks from the start of the metal takeoff according to the production matrix. And here is again, so you can see here on the presentation, like when we have the metal takeoff on this week. This is a good example for one west side. So it's metal takeoff. Next week we have the glass takeoff, and then we jump to the shop use brake shape. Remember that by this time, 1 week before the meeting, the metal takeoff, we have the pre-takeoff meeting. So at that time, and this is very important to mention to you, at that time, if there is some brake shape that are not clear, we need more information, or there is some pending detail on design, there is only 3 weeks or less than 3 weeks. I could say only 2 weeks, because the metal takeoff meeting is here the pre-takeoff meeting. It's here, I mean, and then we have the metal takeoff next week, and we have the glass takeoff. So by the time that we start the shop use break shift, some of the questions that we already talked about on the meeting, it's supposed to be answered on this part, shop use break shift week. So that's the one important thing that we want to mention to you. Like, I know sometimes we're busy trying to fix the metal takeoff, and then we jump to the glass. And by the time that we are on the shop use break shift, there is more and more questions that it's pending. So if you're a drafter and attached to this meeting, or I mean, if you are a PM, be aware like this is very important for us to know by the time that we are dealing with the shop use break shift week. Something we need to know before we begin, it's for example, we need to know the vendor and cut size limitations. For example, when from the pre-takeoff meetings, this is an important question that we have. Shop use brake shifts, and one of the question is, are shop use brake shift required? Yes. So the next question is, who is the aluminum brake shift vendor? This is an example from One West Side, and the answer in this specific project, it was local vendor for unpainted and Paul for painted. So that's good. That's great for us because we know what are the length limitation, and that's the third question of this pre-takeoff meeting notes. What are their length limitations? So according to Paul, standard size, we have this, oversized, that dimension. And for example, if it's a Americlad, that's the length limitation. And that's great because sometimes we can see, for example, when we have a brake shift that it's to cover a mullion, we need to split those parts to align with the horizontals, and at the same time, we need to be on that length limitation. We can do only one single piece because it's not going to be easy for the vendor to create it. But that's an important thing to know. Other important thing to know, it's detail needs to be completed by the time that we're working. And this is a good example to mention. This is from Matilda. When we started working on the metal takeoff, this was the main detail. It's the same page, the same detail. And as you can see, we have only 11 to 16. It's 5 days different between one progress delta to the next progress delta. But you know what? There was a change that is affecting the brake shift, and it's this one here. On this set of drawings on June 11th, the horizontal cover, it was on this position, looking down. But now, on the next 5 days later, the cover, it's in the other, looking up, right? It was flipped. So it is not a huge problem. I'm not talking about like building, it's gonna collapse. No, that's not the point. The point is having this kind of things, we need to be aware of all those changes because we are creating the caps. So quantities are going to be a discrepancy. It's going to be a discrepancy in our quantities because as you can see here, we are considering like one logic on the cap. And this is not a concentric cap. So that's mean quantities is going to be off on those kind of changes. We are going to require more left caps. And if we change to this condition, we're going to require more right caps because it's flipped. So keep in mind that those kind of things. So that's important, detail completed. And this is another example. What about when we have all the information in the details? It's good. For example, you can see one brake shape here. It's 6 inches long. And as you can see here, the node is providing us the specific information with the length for this brake shape and the material thickness. But this is an important thing to mention. We have how many do we need per vertical. As you can see here, it's listed as top and bottom. And that is great because we know that every single time we have that vertical, we're gonna need at least 2 brake shape to attach those mullions into our system. So this is great. This is important to know in our information. Okay, so let's gonna make a small resume about what we're talking about. Something we need to know before we begin. It's important that we have all the CAD file tags in the elevation. So are the CAD field use tags elevation produced and ready to tag? That's one point. Second, is this job part of a campus, and how will that affect our workflow? Okay, and finally, are there any parts we can use from the visual mockup or the performance mockup into the project? Because sometimes that it is exactly the same part, so we need to go to the mockup or folder and then grab those fabs and import into our database and into our DICE folder. So that's very important. Where is when you started, Sean? Did I already pass? No.
No.
Okay, just let me know because I'm very excited talking about this, and then maybe I'm going to be talking more. Okay, the highlighted panel scope, it's then the next step in the process. Once that we pass our pre-takeoff meeting, panel group, it's creating this, what we call it in specific, our own or internal set of drawings from the Delta, but we only added the for panel scope, which is basically the way that we are dividing our process, right? Some other presentation, we were talking about this, but basically we are dividing the work for break shapes, for shop use steel, glazing and shadow boxes panel, field use steel, field use panels, ACM panels, and miscellaneous materials. And then we can start adding notes to that PDF, set of PDF, and then adding more information according to what we needed. If we see any question or something that isn't that clear, that is the perfect time to send an email or call the PM or the drafter to get information on this. But this is our internal set of drawing based on the latest set of drawings. Perfect. And now I give all my attention to Sean.
So some common things we like to look out for while creating the break shapes is first, do we have the details in both top and bottom, top and side views of each part? Many of our parts require multiple views of each part in order to make a comprehensive understanding of how it looks. Do we have any parts that are longer than our max cut length? And this is also, as previously stated, can be found in the pre-takeoff notes. Do we have any parts that look like they may interfere with other parts? And are there any transition details with parts of our scope? Some example of the necessity for top and side views is here we have this steel part here that actually does not just require one side profile, but two side profiles to accurately display all the information that is being needed for this part, including all the welds and the positions of each part in its steel assembly. Here is the completed part. As you can see, each part and how it related to the profiles you saw above, with all the welds and positions of the part in the assembly, and all the information provided. It is greatly helpful in parts such as these. Another example is this part seen here. Important for the welded detail information based on the views below. This next slide. Parts like this are to have multiple views of parts like this is greatly helpful. As you can see here, there's a lot of information that needs to be displayed for many of these parts, and some of them can be quite detailed. All right. An example of cut size limitations is here on Vans HQ. We had a long shop use steel tube that measured 20 feet long with the door opening. And we needed to confirm that that this could be both manufactured and was complied to the structural limitations of one solid part. Parts that may, an example of parts that may interfere with other parts. Primary example is this bathtub end down seen on Stevens Creek on the left-hand side image, that the front this bathtub endem that wraps around the three sides of the horizontal has the front face will interfere with the bottom of the break shape and panels that are attached to the front of the horizontal and protrude outward. And then the right bottom hand picture, our normal standard for a break shape is for the two legs of the bat endem to notch into the or notch around the sill. But in this case, for it to be at that level, the front of the bathtub endem would have interfered with the front extended cover shown below, shown in front, kind of demonstrating how we have to read more into a part than what is initially shown or drawn.
Yes, something I want to add here. It's this is hard for us to catch because we're looking at the only detail set 2D views, like top and side views. And actually, we didn't catch that one when we created the break shape. We only created the endem there, and then we finished our process. But then later, during the field use fast process, one of the PC, I think it was Joe or Carlos, they catch that one like it was hitting with this. So as Sean mentioned it previously, it was an easy solution, setting the endem not at the top of the sill track, but it was at the bottom of the sill track. But as you can see, some of these things are continuous improvement for everybody, as us for break shaping.
And finally, many parts are not quite accurately shown within transition details and are only really capable of being having their presence discovered by reading the full descriptions on the side below. If you see where the 5 is pointing, the number 5 arrow is pointing that the shop fabrication assembly description in number 3 lists that there is a cap required at that scenario there. In beginning our task, the first step is to find a part, open its detail in CAD, and create a W block of that break shape, according with our naming convention. On the left, you can see the database base where most of the parts will be entered into. The center image is an example of a profile of what looks to be a break shape endem profile. Where's that place? And finally, once that profile has been W blocked, it'll be saved into the dies folder seen on the right. Next step is to add part information into the database, into the UD window seen on the left under our BSXXX detail, where all our break shapes will reside and have all their parts and information entered, such as their part number, their paint finish, their fixed length, and or their adjustments on top or bottom, and any other information, such as if it's designated shop use as, meaning it will be part of an assembly of other break shapes. Then to create on the field use tags elevations, to create tags, a tag for each part location, to UPD that elevation, and then QBIM the part in order for the database to extrude the profile as seen in the page before to the designated length in the UD window. Finally, with the QBIM part, it is important to add all the necessary holes and notches according with the drawings from the Bluebeam, and then create and then add all the important information in the fab so that way it can be fabricated accurately. And now a short video to demonstrate this process.
Okay, does any one of you have questions? I mean, before we pass, we're gonna have at the end of this presentation, just a couple minutes to talk about the question, but if you have any question, feel feel free to ask, Frank, or just adding to the chat. Okay, I think we're good.
Yep,
Okay.
nothing on the chat so far.
Perfect. So let's gonna see this video from Sean explaining our process. Oh, I think I need to hold on, stop share. Yeah, then screen 2. There you go. Okay, I apologize. I need to share with audio.
I've selected this small angled break shape on detail 554B on one west side. In doing so, I've created a profile of the part and entered its information into the BSXX detail on the UD window of the database. For part number, I have named it after its detail number and the fact that it is the second profile or second break shape profile from the face of the building. To enter it into the project, you enter W block, select your profile, and under the dies folder, you give it its name that I've already entered in, BS1554. B-2, save. With that entered, the database will be able to read this profile to make its part. The part exists here on detail on elevation 211 on one west side. In order to make a tagline for the part, go to www takeoff metal tag. Here you can enter in all the information that you need to display for the part. Distribution index is always 1 for break shape parts. Elevation mark number for us is actually, we enter in our filter BS for the database, BS-32 for his elevation 32. And detail is always BS-X.XX. Click OK. And from here you can enter your tag, which is going to be 8 inches long, right here, according to where I've found it in the drawings. For our process, we always set our parts, break shape parts, to magenta taglines. And once that is in place, according to where it exists on the building, from here you can UPD the elevation to get the database to generate the part. From here, I'll ask how many BS-32 elevations there are. There is 1. And it'll ask if you want to name the part MM. As its prefix, as always, no. For us, our prefix is BS. Click OK. And the database says run UPD. Opening up tag layer 4 will show you that it has, and it producing text will show you that it has generated your part with a mark number. To open up your fabs, you're going to want to hit QBIM, enter. QBIM your tagline. and the database will create your extrusion, seen here. From here, it is preferable to create all necessary notches required for the building, or for the part. We see here that it does have a fastener, an O3-B-P, that is 7/16 from the edge on the 1/8 surface. 1/8. To create that notch, you can simply produce a circle. That specific fastener requires a hole of 0.201 diameter. Make sure we're producing on the right face. Move it down to the correct dimension. And as an 8-inch long part where 2 of these fasteners are required, as I would suspect putting it 2 inches in from each side and see how that looks. Extrude the profile of your notch and hit this notch feature right here. And then with the notch on one side created, you can copy and paste the notch to mirror onto the other side of your profile. So now we will have 2 holes for our fasteners on each side of the part, as 2 were required for this bracket. To continue, from here, open Fab Template. And from here, a fab will be generated of your part. And it's from here that you add all the necessary information that is required for this specific break shape. Fast forwarding some, I have completed the part with all required information, including angle, part dimensions, hole locations, hole callouts, an isometric view, and general information about the break shape required. Save, and this part should be ready for checking. For the purposes of demonstrating, that ends the video. For the purposes of demonstrating how
Okay, so if you have questions about our process, this is a good time for you. If not, we can continue. But we have communication and changes after takeoffs have been completed. This is another important thing we want to discuss with you in this presentation. As we know, there is not a perfect building, and all the times we are having continuous changes. And that's part of the construction process. We definitely understand that part. But when we have new parts or changes in the existing parts added after takeoff, it can be missed if it is not properly communicated. So some of the things that when you have a project and one of the brake ships are added or are updated, it is a good moment to send an email to us back saying like, we haven't updated and maybe we need to, and that's important to mention, maybe we need to go back and revise what we released and what is known on the details. So this is very important to mention. We have some examples when we did something based on the details, but then later it happened something different. And this is from natural resources. As you can see on the right side, the detail it was showing like extrusion, like a channel to attach the mullion to the floor with two holes for bolts, and it was called as an extrusion. So when we see this kind of thing, we know that that is not part of the scope. This is more an extrusion, and later during the process, when they're doing field use fabs, they need to create the fab for that extrusion. And I think there is a little bit more in story in this natural resources, because later it was created as a brake shape for when they were working on the fabs for the field use. And as you can see here at the top, here is the fab, which almost the same size and all the information for the brake shape. But originally it was an extrusion, and that's why we never released it in the package for shop use or field use brake shapes. But the PM spent a lot of time looking for this into the original package and went to the field use brake shape package, and it was not there. But it was only on the release from the field use fabs. So this kind of things, it can improve better if we have communication, right? Like, for example, if you have to create a brake shape, that is great. We don't see any problem doing that. But maybe to save time to the PM, maybe you can add a note into the email, like, I created a new brake shape, but it was not added into the original release for the package for the shop use brake shape, or even field use brake shapes. Or another option, it could be like, you can let us know and we can jump back and do the fab for you if you really need it. I understand like everybody's busy and we are dealing like last minute change, but this is part of our continuous improvement, right? Doing better all the time. So this is only one example about changes. Another example we want to share with you is, for example, sometimes some of the details are very early on the process, and there is a lot of things that the drafter needs to be handling. And when you are looking at very specific details to create that part, it's coming more and more questions, and probably those parts are not really the best solution. And this is an example for Matilda. Originally, on the original package, it was creating this for this extender cover that is 9 3/4 long. It coming for one splice sleeve, and you can see the way that it was drawn there. It was like a plate, but it was a note at the bottom, like saying it was welded splice sleeve, but it was not a call out for the welding, and this was not the best solution. So we spent a little bit more time trying to think about it, trying to see what was the best solution. And we were talking to Pedro and some other guys there, and they gave us more information about how was the solution in other project, like Cal State. They use the same extrusion splice sleeve here, miter it, and attached to an angle. So we went there, we found the fabs, and we sent it to the PM, and they took the decision. But the point is, like, this kind of things, for example, we spend more time trying to figure out, and that's part of our process too, and our work, and we are always in continuous improvement. Very good. I see one question. What is the lead time for brake shapes? Okay. We normally have 1 week to complete the task, but I cannot answer that question very specific on the time, right? Because, or what do you think, Sean?
Is that a PM question, or is that like after order? How long before they or
So
purchase?
if you're talking about the production lead time for brake shapes, I mean, typically really depends upon the panel manufacturer's lead time, who we're getting them from. We typically go through Pole or Mericlad, possibly California Panel Systems. So it really depends upon their lead times. But if we can get at least 8 weeks for them to fabricate, they send it to the painter and then back to us. That's about average.
Okay, that's good to know, Heather. Thanks for sharing with us that. Okay, perfect. And there's one more thing coming from Jenna. And can you talk about how do you handle if brake shape needs to match to the new die and it didn't, and if the brake shape needs to match to the new die and it needs to match to the extruded part. Okay. Yeah, maybe we can cover a little more, a couple minutes more. Yes, okay. So let's gonna see some of the possible venues for future improvements. So we have Inventor. We're a hub. As you can see here, we have some Inventor fabs, and quality are getting better because you can see more through the details and the fabs, and it's an easy way to create an part still because Inventor, as probably you are aware, and from our last presentation, we were more Inventor is more related about the process to create parts like holes, the specific size hole, or welding information. So it's better when we are working on Inventor. It has some advantage and disadvantage. This is one of the advantage we have. We have fabs, which is more accurate, and the views are cleaner, as you can see. This is exported from Inventor, moving to or CAD system, and then the takeoff program. But maybe that becomes one of the disadvantages because it's quicker and easier for modeling. It's easy when you're using Inventor, but it's a slow export process with unnecessary steps because you have to create a fab on Inventor, and then you need to export it to CAD, and that's an extra step. And then when you have it on Inventor, on CAD, again, you need to redo or at least make some adjustment into the fab to create parts again on CAD, and it could be easy in one way, but at the same time, we are spending a lot of time. And finally, it's a complicated process for making updates. If the part needs to be changed, we need to go back to the main source that it was Inventor, and then do the updates and follow with the same process, right? Continue to move to CAD, exporting to CAD, and then again, moving to our takeoff program. So it can be tricky sometimes. So before to do something on Inventor, maybe that's one of the questions that you are thinking right now, when we're using Inventor and when we're using CAD, well, our main goal is to create everything on CAD, on our takeoff program. That's our main goal. If it's very complicated as a function bracket with a lot of bands and hard angles, is that when we decided to jump to Inventor and follow with this, because maybe the time that we're going to be spending creating the part on AutoCAD, it would be easy to create it on an Inventor. So before to do that, we need to discuss exactly, is this a good option going directly on CAD or Inventor? If it's not, then we go back to Inventor. That's the idea. Okay, so that's cover our presentation, and I have one question pending, and I will answer it. Basically, Jana wants to know how do we do when we have a dice change? Well, let me show you what we are doing. What we've been doing recently. Before to have any problems, let's see, I think I can share my presentation here. Give me 1 second. Okay. Okay, working. During the checking process, we are creating our own layouts, and I'll show you. On the shop use break ship, we have layout break ships, and that's part of my process, for example, to create. I'll show you. I know, like, for example, some of the dice, okay. Some of the dice always are updating, and that's one of the reasons when we, for example, this is the detail. So we are checking not the extrusion, not only based on the detail that it's coming from CAD, we are checking based on the dies profile. So that is one way we can avoid problems about updatings. Sometimes we can see like the die is completely different based on the detail. I haven't seen this very recently, but at least I saw it. Like the die, it was completely different from what it was shown on the detail. And the reason it was because by the time that the details it was created, it was an update on the die. So that's one way we are catching those changes. If it's not matching, we are following what is on the dies because that is coming from Western. Okay, I don't know, maybe that's, is that clear about the question? Is that answering the question? You want to add something? Anyone want to add something to this?
I have one more question, Saul.
Okay, Jose, yes.
During the process or before you start the fab drawing, we usually review what's detailed in the shop drawing. Sometimes it looks like the clips are extruded or brick shape. When you guys decide or you guys discuss that first, that we decide to change it with break shape or the break shape change into as an extruded clip. Because even the final fab, we found out that some process that we forgot those clip because it's shown as an extruded clip. But the extruded clip might not work during the final fab. So we end up going back and make a break shape.
Mm-hmm. Yeah, that's a good question. Well, let me think how to answer. Do you have any thoughts, Sean, about this question?
No, it kind of sounds similar to that one example you were showing from NNR where it was initially displayed as an extrusion that changed eventually to a break shape. But
yeah, so that's right. Yeah, so I'm sure, Jose, like and we understand that part, like something that it was drawn, it could be not the best option at the end. So I don't have any specific answer to your question because we are creating what is based on the details, and sometimes it can work or sometimes it can be improved based on the details. So if like this example, if you see something and you think we can improve or you think on the detail, based on the detail, we can make an adjustment. So that's a good time you can tell us like, hey, this is not gonna work and this is the reason. But sometimes as we were talking about time frame, it could pass months from our release by the time that it was created in the app. Mm-hmm.
That sort of leads into Sherwin's question that shop use break shapes are released early. How do you deal with changes if the drawing was changed after a month or more?
Yeah, we don't have, for be honest, we don't have a process very developed. Some of the reason I think that's one of the reason why when by the time that you're working on the fabs for the units or for the field use fabs, that part it's completely different that it was released. I think this is very good opportunity to continuous improving how to develop a very good process about the changes if it's something changed once that we release it. But the very flat answer, it's as soon as we release it, we think like everything is gonna be okay. But yeah. we are sure like that's not the way.
Something I'm currently in a Kaizen with Chris, and we're going over currently a process for trying to improve the tracking of changes that happen after takeoff, and that is something that is currently being looked at right now, and at least tracking and keeping organized the changes that happen after takeoff has already occurred.
Yes, that's a good idea. Yeah. So we're gonna be working on that part. Yeah, I like this feedback. Yeah, to provide better updates on the drawings after it was released. Okay. Any other questions or any other comments? Any other feedback? Something you think we can help us to improve our process for shop use, brake shape, and steel?
So one of the things that you guys were talking about was that occasionally you'll have something that you see that happens during the units by week, and the team that's doing the fabrication on the units may see either a brake shape that was or wasn't in the package, or it needs to be updated or modified. But are you also seeing that there's sometimes a request from the fab team to create a brake shape for a special condition that you just can't see in the shop drawings?
Yes, the answer is yes. We saw it, not very frequently and recently, because I think what you guys are doing, it is great. Like the main stage, looking at all those details. But I can say, I don't know, Sean, what do you think? Like in the past year, we haven't seen this, or what do you think?
Yeah, I believe it has drastically reduced the number of parts that are just impossible to really see without just digging into just random parts of the building to see if a brake chip would be needed there.
Mm-hmm. Yeah. So what do you think, Sean? I mean, Bill?
Yeah, that pretty much gets to what I was asking, is just, maybe we are seeing something that you can't see in the shop drawings, but as we put the details and the actual fabs together, you might be able to tell that there's some odd shape or something. But one thing that I'm wondering too is that if we do a situation like that, would it be something where the person building the unit actually just makes the brake shapes and asks you to release it for them, something like that?
Can I comment on it, Bill?
Sure.
So generally our process, if we have to add the brake shape and we're releasing it this week, right? We are giving it, and if it's a simple brake shape, obviously something was missed, we're adding the brake shape ourselves on a FABS release. We have to create shop work order for it, and we have to notify PM. So PM shouldn't technically be looking for it, like in the brake shape package, because we know when we're missing it, and we're always creating shop work order and we're notifying the PM. Yes, this brake shape wasn't in the package, but and I think it's a little bit like the timing is a little bit like rushed when we have to create brake shapes ourselves. So I don't know how much we go back to Saul if we have to release, let's say, tomorrow.
Mm-hmm.
Yeah, that's true. We're just adding an extra work order for that, any additional parts like the brake shape or miscellaneous parts when we're releasing the unit files.
Yeah. Yeah, actually, if you are, I mean, if we can say what we prefer, it's if you can create the fab and just send us an email, we can do the release. So you don't have to worry about creating a shop work order or dealing with anything. We can take care about the process of the releasing. And at the same time, we are very sure like the brake shape that it was created, it is accurate based on what you really need. That's if you asking what do we prefer, right? But I don't think we have developed any specific process about that.
No,
but good point.
This is why I asked about the lead time, how much it takes for the vendor, because you're releasing it with intention, the vendor to fabricate and paint it. And for these brake shapes, we would go through you, we have to. But if it's a brake shape, something could be made in a shop, I don't think it makes sense to go through you because it needs to be there like next week when the fab's going, and it's still our shop, and shop needs the shop work order.
That's true. Yeah, that's a good point. Okay, no, that's definitely a good point. Okay, thank you for the feedback. Anything else? So many questions, so many other comments.
Just one additional thing. So you didn't show too much about once you're done creating your package, how do we see those? I know the checkers, for example, will want to do those comparisons as we're checking the final fabs to see what is it that we released and just make sure that they're working on that final fab stage. So maybe just touch base on where do we see those parts that you've released so that we can use those as we're checking units.
Great. Yeah, that's a good question. Okay, so we're following, once that we finish our release, we're following what is on the standard. I'm going to mention to you, but I'm going to explain exactly what's the process for a release. We're following exactly the same steps that you can see here on the shop use brake shape on Swiss. And it's here, final brake shape or still release. We are following all of this process, each one of single. And basically where we can find it, well, if you go to the main project folder, like let's gonna say, where is one project like we've been working, let's gonna say Google Gibraltar Building 4. So when you are on the project folder, you can go to drafting, and then the final release, it's drafting fabs, and then here under fabs, you will see shop use brake shape folder, if it's an existing shop use steel release, and if we have sunshade bracket release. So what is our final package look like? Well, we have an AutoCAD fabs on a zip folder. We have the fabs, and we have the elevation base with the marks. So you can see here our final release. It's giving you a distribution list with the part name, the mark number, total quantities, and everything is to the shop. So it's gonna be matching all the time. So you can see the fabs coming from here. Sometimes when we are releasing, we need to do some updates, and when we need to change everything on the server. But this is the final location when you can find our fabs. So again, it's on the job folder, drafting, fabs, shop use brake shape. We have 2 more locations I can show you right now, but this is the main for everybody looking at it. We have the Prochman release on the folder, and this is exactly the same on the materials, and then we have exactly the same folders. So that's the second place. And we have an archive place when we are saving all those fabs. It's under drafting takeoff, and then materials release 2 p.m. We have an archive of the same releases, see? So that's more or internal or personal for the department.
So do you guys save the dice for those AutoCAD files, or you just saving AutoCAD files of the fabs?
No, we're not saving the dies. We're only saving the fabs on the zip folder. I noticed like we had some issues, right?
Yeah, we had issues because it was overwritten because everybody, maybe as for right now, when we're working from home and everybody overwriting like the main folder, maybe it's a good idea to back up the dice also of the moment when you release.
Yeah, you know what? That's a good idea. That's a great idea. I think, Sean, we can start doing an archive or saving our dice. Yes, definitely. Yeah, that's a good idea. Okay. Yeah, we're going to be developing more this idea, but that's a great idea. Definitely. I like it. Thanks. Okay. Any other question? I think we're still having time, or any comments. That's great because it's coming a lot of continuous improvement for our side. That's great. Thanks for all your comments. Okay. Okay. Well, if you are thinking more comments, let me share you how it's looked like the continuous improvement. Right now we have new direction about the 316 end materials. We received instruction to create it with the new thickness, or this is the new thickness for the endems. But it comes to a couple questions right now. As you can see, header, it's aware of that. And we're trying to develop this too. We found some of kinds of things like Steve, it's looking at it right now with the help of Chris Green. But those are the things like it is great for us to know. So when you have this kind of problem, like Heather tell us, like she's having issues with the vendors, that's perfect. You can send us an email, and then we can be aware and we can make small adjustments. Because we were thinking like changing the thickness to the material, it was not a huge problem, and nobody will have any issues because we were fixing another problem from the field. But now we're looking at it that we have more things to think about it. So that's part of the continuous improvement. Any comments about the 316 end and materials from you guys?
Yeah, the biggest problem was just we could buy the sheet anodized when it was thinner, and then when it was thicker, we had to get it in mills. So now it's a question of the finish. So I think where we left it was we were gonna make them long and then cut them in our shop. But
Yeah, we're gonna make them long, paint them, and then cut them.
because small parts, when you paint them, get really expensive. So that's why we're gonna kind of avoid that, you know.
Correct. And then it was getting really expensive to source the pre-anodized sheet. If for some reason we're going to make them in the shop, so we'll just keep them as part of the break shape package, going to a vendor.
Okay, great. So we are going to be releasing like we normally do it, right? With the same finish.
Yes.
Yes.
And then we'll buy them long and the shop will cut them up. So.
Perfect. That's great.
So Saul, you talked a little bit about Inventor, and you said you sometimes do them in AutoCAD, you sometimes do them in Inventor, right?
Yes.
So why would you not just do them all in Inventor? Because it seems like a simpler piece of software to use for this type of process, you know what I mean?
Mm-hmm. Yeah, some of the reason is because our brake shapes are always attached to the units. And the operators, they are asking to see our brake shape into the QB model based on the takeoff. So we can create it. We can export the Inventor file to a CAD file and then adding to the dice folder. So I'm aware we can do that. But if we could find a direct bridge between the dice folder on the takeoff from Inventor, skipping the export part, I think that would be great. That's saving us time.
So we experimented with that, you know, because the output from Inventor, you have two different choices, but you can do a DWG as the actual visual of the model. So you have your IPT, which is your part file, and your DWG can be the actual view file. So when way back when, what was his name? The other guy, a long time ago, can't remember his name though. We played around with this a little bit, you know, to have just it be a regular AutoCAD template file, you know, that the takeoff group could, you know, use for their process, but it could be the output from the IPT file too. So there is a way to do that where you don't have to do an export, you don't have to do anything like that. It's just it's the file that comes off the IPT. So we could look at that if you wanted to.
Yes, definitely. Yes, we can look at it. We really appreciate your comment. That will help us for us. Yeah, that would be great. Yes.
Thank you.
Just because whenever you have to make changes, the Inventor file is so much easier to make changes to. If you have to move holes or notches, or it's just so much easier to control that way. So.
Yes, definitely. Okay. Very good. So that's all what I have. Any comments, Sean, or something?
No, that is all I have.
Perfect. So we really appreciate your assistance to this presentation, and just feel free to send us any email or question you have. We are here for help you. Thank you.
Nice job, guys.
Thank you, Saul. Good job.
Thank you.
Thank you. Good job.
Nice job.
Great job, guys. Appreciate it.
Thank you.
Bye.